Alrighty, this is day 2 for section 4.1. We're going to be looking at polynomials again, but instead of looking at, okay, here are the roots, write the polynomial, today we're going to go the opposite direction. So if you have the polynomial, how do you find the roots, whether they're real or imaginary? So we're sort of starting this odyssey with things that solve easily to get the zeros, to find those, and then as we go through the next part of the chapter, we'll look at what happens if they sort of don't work well in terms of factoring. So what you're looking for when you're trying to find a zero is you're trying to see what values for x make that equation equal to 0. So we set our polynomial equal to 0. Now when we do this, we look at the degree and try to decide how's the best way to solve it. So if it's degree 2, the easiest way to solve if it works is by factoring. So I'm going to try to see if I can solve by factoring to make this happen. So for the first one, I can break it into 2 binomials. Okay, so there's no GCF, so I don't have to pull anything out. But when I break it into 2 binomials, this would be x and x, looks like plus 3 plus 2. Set them each equal to 0 and solve. I know you can do that in your head really easily, but if they're not easy, make sure you remember what you're doing there. That's that zero product property. So I get those 2 solutions, -3, -2. What does that tell me? Well, they're both real numbers, so that means this graph has 2 x-intercepts, 2 real zeros. So imagine in your head when we drew all those pictures, it's crossing the x-axis then 2 times. So I have 2 real zeros, 2 x-intercepts. So when we make a sketch, we for sure need to have those points on there. So -3 and -2. Now here's the goofy thing though. I really don't have a lot else to go on. I know the parabola opens up, right, because my leading coefficient's a 1, and I know something else about the graph by looking at the equation. That number right there, the +6, would be what point on the graph? Well, that would be when x is 0, y would be 6, so that's your y-intercept. That's something else you can always put on the graph. So I'm going to put that on there. Now we know these parabolas are symmetric, so I have a little bit to go on, but you don't really know where the vertex is. All I know is it's between the -2 and the -3 and below the x-axis because it's opening up, but I really don't know a whole lot else. And that's okay, we're just making a rough sketch. But if I know this point on the y-axis is over 2 up 6, that means I could also go over 2 up 6 on the other side if I wanted to, just to get that symmetry. Give me a little bit more to go on, and then I have a parabola that looks something like that. So I can get a pretty good rough sketch just by knowing the zeros and then the y-intercept. So that's an example of a degree 2 that has 2 real solutions. It worked nicely because this expression was factorable. All right, let's try another degree 2. We're going to work through all the possibilities here. Second degree 2, it's trying to see when x² plus 9 is equal to 0. Now, is that one factorable? If it were a negative, it would be, but not with a plus. So I really can't solve it by factoring. However, you could solve it just directly for the x because there's no other term. So I can get the x² by itself. So subtract the 9. So the just solve it works just great. Square root. Now this is why we talked about all of those imaginary numbers, so we're kind of warming up for this. Square root of a -9 is not real. It's not a real solution. So when I think of that, it's going to be plus or minus, remember, square root. I think of it like this. -1 times 9. Separate out the imaginary from the real part. So the square root of -1, that's your I. Square root of 9 is 3. So it'd be plus or minus 3i. So I have 2, important is you don't forget the plus or minus, 2 imaginary solutions. I knew I had to have 2 answers. It's degree 2. They're imaginary. So how many x-intercepts would this graph have? None, because it's not crossing at all if you have imaginary solutions. So this is 2 imaginary. That means there's no x-intercepts. Well, you knew that. Look back at the equation, huh? What does a plus 9 do to your graph? Moves it up 9. So that means my graph, I'm just going to guesstimate here, is going to have a y-intercept of 9. And then since it's a value of 1, I know I can go left and right 1, and I can get a really good sketch very quickly. So 2 imaginary solutions, no x-intercepts at all. So let's talk about something then. What you did in this part 1 was write the polynomials by knowing the roots. So now that I know the roots, I want you to think about how you could write that as a product of linear pairs, of linear factors. So x minus 3i and x plus 3i would be doing what we did yesterday with these roots. If you multiply these two together, you get back to your x squared plus 9. That's where that comes from. So 3i and negative 3i are the values for x that make that statement 0. So that's kind of looking at what we did yesterday as well. So no one would ever think to factor it this way because they're not real numbers, but those are the linear factors that make that polynomial. Okay, one more degree 2. So take a look at this one. We're trying to see when x squared minus 6x plus 9, when does that equal 0? So we're trying to see when that's happening. So when we look at that value, this one is factorable. So x and x looks like a minus 3 and a minus 3. Okay, so what's the story on this one? Both of your linear factors are the same. I get x equals 3 for both of them. All right, so see if you can remember from our pictures yesterday, what would that mean? What would that look like? So if I have both of the same factors, what point of the parabola would be on the x-axis? There's only one x-intercept. Technically two real solutions, they just both happen to be the same thing. That's the vertex. This is a double root. So that's what it's going to look like when you factor it. You're going to get two linear factors that are identical. Okay, now what other points can we put on the graph? Well, we know it opens up. It's positive 1. I can put my positive 9 up there. So that means it's over 3 up 9. I could do over 3 up 9 if I wanted another point. You could also, because you know where the vertex is for this one, go left and right 1 and up 1. Right, because it's the regular opening, regular steepness. So just so you have enough points on there, try to always put the y-intercept though too, because I think it's important to see that that value comes from the constant. All right, so degree 2, we went through all three possibilities. 2 real, where it's a double root, 2 real where they're different, and then 2 imaginary. All right, so let's take it up a notch here to some higher degrees. This one's degree 4. So degree 4 means that you either have all 4 real, all 4 imaginary, or 2 of each. Remember, you can never have an odd number of imaginary. So we want to try to see what makes this 0. Now, I said everything's going to work nicely today, so that means this one must factor. So let's see if we can break it down into a product. So what multiplies together to give you an x to the 4th? Well, that would be an x squared and an x squared. Look at your middle term to help you. So whenever the middle degree term is half the degree of the first one, you're always going to be able to factor it into binomials if the numbers work out. All right, then you want to multiply to negative 2 and add to 1. So plus 2 minus 1. So I get 2 binomials. Set them each equal to 0 and solve. All right, well, the second one's not so bad. This one would either factor or you can just solve for it. Add 1, square root, and we get plus or minus 1. So I know right now I have at least 2 real solutions. I have 2 real number answers. Try this one, though. When I solve this one and square root, I get imaginary solutions. So plus or minus. Now remember, think of that as negative 1 times 2. Square root of negative 1 is I, and then square root of 2. I like writing the I first. For me, that's easier to look at, because if you put it after, it's kind of like, where is that I supposed to be? Under, not under? I think that's easier. 2 was not a perfect square, so leave it as a radical. It's a lot easier to look at. So they're not all going to be nice numbers there. And our other 2 are real. So I have 2 real, 2 imaginary solutions. When I make my sketch, the only real ones I can put on there are the 1 and negative 1. The only other number I can do is the y-intercept, which is negative 2. Now take a look at this equation. This equation is even. All even exponents, constants are okay. Do you remember what symmetry even graphs have? They have y-axis symmetry. So I know, just kind of by looking at what I have so far, that's the only option I have left for drawing that graph. So when you look at those points, those are your zeros, your y-intercept. It's a degree 4. So 2 real, 2 imaginary solutions. All right, let's move on to degree 3. So try a couple degree 3. When you solve degree 3, you're looking for the same thing. You're looking for the values of x that make this statement 0. So let's talk about degree 3 for a second. Degree 3, think of the end behavior. Is it true that every degree 3 would have at least one real solution? Would it cross the x-axis at least one time? And the answer to that is definitely a yes, because if you have one end of the graph going to positive infinity, the other going to negative, you're going to cross the x-axis. So I know there's at least one real solution. Could be 1 real, 2 imaginary, or it could be all 3 real. So we have both of those possibilities that we could be looking for. So lots of different ways that that could happen. But you could not have two or one imaginary and two real. That could never happen. Imaginaries always come in pairs. So let's see what we're going to do on this one. There are 4 terms. So hopefully the little bells are going off in your head here for factoring. 4 terms means factoring by grouping, where you look for those GCFs. So we group the first 2 together and the second 2 together. So we're going to pull out the x squared, and we're going to pull out the 4. And then in grouping, think of this as your first term, and that is your second term. And what you're doing is pulling out again what the GCF is, the greatest common factor. In this case, the GCF, what appears in both, is the binomial x minus 2. So we pull out that binomial factor. What's left in the first term, if I pull out the x minus 2, it would be the x squared. And what's left in the whole second term, if I pull out the x minus 2, would be the 4. So set each of those equal to 0 and solve. So for the first one, that would be x equals 2. The next one, not as nice numbers. When we set that equal to 0 and we subtract the 4, we're going to end up getting imaginary solutions. So plus or minus, and remember, think of that as -1 times 4. That would be plus or minus 2i. So we have 1 real solution, 2 imaginary. So 1 real, 2 imaginary answers. Okay, so how many x-intercepts do you have then? Same as your number of real answers. So I have 1 x-intercept at 2. The only other number I really know is the y-intercept, which is down here at -8. Have to guesstimate a little bit here when I look at these. So let me erase so I can get rid of some of this work here. All right. So let me put that down here at -8. Now, end behavior we know. For x to the third, we know it has to go to positive infinity and negative infinity. I don't really know exactly what the story is with how that looks, unless I did more xy points and tried it, but I think for just a basic rough sketch, that would be plenty. I've got my x-intercept, I've got my y-intercept, I know my end behavior is correct. Okay, last one, degree 3. Again, a little bit different kind of factoring though. There's only 3 terms. So 3-term things factor into 2 binomials, but remember what you look for first. GCF, there's your little hint on this one. Pull out an x. And when I do that, I can factor that trinomial further. So that would be x plus minus, do as much as I can here. Now they multiply to 15, add to -2. So that means it would be -5 and a +3. So your 3 zeros would be 0, -3, and +5. That's 3 real answers. So I have 3 real solutions for this one. If it's a degree 3, that's all of them. That means this crosses the x-axis 3 times. So I have 3 x-intercepts. So go ahead and put those on there. So I have -3, 0, and +5. Okay, now end behavior is kind of tricky. This one, I already have the y-intercept, right? There's no constant out here. That's my 0. So I just have to do the end behavior, which some people have trouble drawing this. But if you're starting at negative infinity, you're going to have to come up through that 0, back down, and then you're going to have to cross back over through that one. So I'm going to just get a very rough sketch for this. I don't know what the height of that point is. I don't know what the height of that point is for sure. I have to guesstimate here a little bit, so I'm just making a rough sketch. If I wanted to actually put in more values for x, I could. I just want to get the general behavior of the graph. So I know it has to come up, it has to come back down, and then it's going to have to go back up again. 3 real solutions. So the second part of this 4-1 is, okay, if I give you the polynomial, can you tell me what the zeros would be, whether they're real or imaginary? So today we can solve by factoring. In the next few sections, we'll talk about other methods to solve if factoring doesn't work.